Hello and welcome. This is your Algebra 1-2 Chapter 7 review. I'm with you here in the morning. It's March 24th and it's 7:14 a.m. so you know the drill. I got to get through it quickly. So this is based on homework number 24. That's the practice problems that I'll be looking at. There are some that I'll be skipping. I'll be looking mostly at the proficient and advanced ones because I have a feeling that if you know the proficient and advanced, you can definitely get the basic. And I think that's where most people are at as well. Now, if you're at the basic level, you have to remember we get to that level as well. So I do have to hit on all these points. And I'm going to be coming from an aspect that you've heard it before, that I've taught it before. So this isn't a video to go and saying I don't know any of it. Maybe you'll be able to learn it from there still, but I'm not going to slow down for that. Remember, I got to be careful on time. So a lot of basic stuff I'll be a lot of the basic problems labeled basic I'll be skipping. Okay, starting with slope practice problems, finding the slope of a line. Slope is rise over run. But this chapter, we've been defining it more as using 2 points and finding the difference in those 2 points. So slope, as we've also been calling m in y equals mx plus b, it's rise over run, but it's also how much you rise is how much you change in your y values, how much you change in your x values. So change in y values you can do in one of two ways. You can either count it, right? You can literally count how much you've changed in y and how much you've changed in x. In x. Or you can do a subtraction. If you have 2 different points, you can subtract one of your y values from the other y value and one of your x values from the other x value. All those subscripts means is here's a pair x1, y1, here's a pair x2, y2, and you can subtract one y from the other and that one x from the other. And then you'll find that change in y over change in x. Now the proficient level here, I forget what the basic one looked like. I have a couple problems here. On the proficient level, I'm going to rewrite this in mx plus b form so the slope is first and the y-intercept is second. Now, I already know what slope is. It's the guy that's attached to x by the hip. There's my slope of 1/2, or 0.5 if you will. This one's a little different here on number 5. On number 5 you have, if you want to write this in y equals mx plus b form, your plus b is plus 2. What value's in front of x to make this happen? Well, it's 0. If this were to be written in y equals mx plus b form, m, your slope would be 0, and that's what that one is right there. So your slope in this case is 0. Number 6. This is in y equals mx plus b form. It kind of doesn't look like it because the y's on this side, but let's write the y over here. Y equals 4x minus 3. So my slope is 4. If I wanted to, I didn't do it. I didn't have to do it for this one. This one was already a fraction. If I wanted to and write it as rise over run, this 4 is 4 over 1, like that. Otherwise 4 will work, but if you want to graph and really understand it, it's good to write it as a fraction. There's no problem with having a fraction slope, absolutely none. I'm actually going to skip 7. I'm going to go back to it, but I'm going to do 8 and 9 first as I go through. Okay, number 8. Easiest way to find slope, in my personal opinion, is to solve for y, meaning get y by itself, so you can get it in this form always. This is the one I've been getting in these last problems right here. You can see mx plus b and find your slope m. So isolate y, subtract 3 from both sides. We'll get 2y equals, now these don't combine. This is 8x and a negative 3. Those would not combine. Now I'm going to divide by 2. And when you divide by 2, you divide everything by 2, including that negative 3. Don't forget it was negative. So this becomes y equals 8 over 2, which is 4x, and then minus 3/2. If you were to graph this, or 1.5 if you'd like to say, if you were to graph this, it might be difficult because the fraction y-intercept, but your slope is what you're looking for, and your slope, once again, is 4, or 4 over 1. Not that we are yet at that point, but if I were to look at number 6 and number 8 here, and I were to graph them, these would be parallel because they have the same slope and they cross at a different y-axis, which means they are not the same line. Number 9, same idea as number 8, get y by itself. So I'm going to subtract 6x over here. And I will get 3y equals, remember these don't add. A lot of people would say 8 minus 6x, but to get, once again, familiar with that mx plus b, mx plus b idea, I would very much like to instead have the x term first, even though it's negative. Divide both sides by 3. You're going to get y equals negative 6 over 3 is negative 2. Negative 2x plus 8/3. Please don't try and round that fraction. It's an approximate fraction if you do. And my slope, once again, in mx plus b is negative 2 or negative 2 over 1. Remember, over positive 1. Okay, back to number 7. This one's a little different, and it would be much better if I described this through a graph. But I'm going to do as best as I can here. You know what? I do have to describe it from a graph. X equals 5 means that no matter what y equals, x is always 5. This is not a point. This is a line. So here's 1, 2, 3, 4, 5 for x. Here's a point where x equals 5 when y equals 0. Here's a point where x equals 5 and let's say y equals 1 and 2 and 3. No matter what y equals, when I go up forever and down forever, x will always be equal to 5. It appears as funny to some people because they see x and they imagine, oh, x goes this way. Well, yes, x does go this way. But x equals 5 says no matter what y equals, this x value of 5 will always be true. So it's a vertical line to represent that. So let me draw that with the arrows. There we go. Let's say that was a vertical line. You know what? Let me actually do a vertical line. Pretend like it was going through those points. There's your vertical line of x equals 5. Now, the question was not, they didn't ask you to graph it. You might be asked to graph these, but they did not ask you to graph this. I need to draw this, though, to get you the understanding of what the slope is. Slope is all about change in y over change in x, rise over run. Let's say we had another graph here in green like that. I could pick 2 points on this graph. I could say, how much do I rise from one point to the next? You count that up. That would be your change in y. And how much do I run? That would be your change in x. You take those values and you divide them. You divide this delta y over delta x. When I do a vertical line, maybe I take 2 points, maybe this one and this one. Excuse me. And I calculate my change in y. It goes up that much. Awesome. But what's my change in x? Do I run at all? And the answer is no. I don't run at all. My change in x is 0. I don't run. Yes, that's pretty much all I have to say. In other words, this point, let's say this point is 5, negative 8, and this point is 5, 3. My change in y will be 3 minus negative 8, which is 3 plus 8, which is 11. My change in x will be 5 minus 5, which is 0. When you're doing 11 divided by 0, you can't do that. Right? You can't divide by 0. You need to know. Cannot divide by 0. So what the slope is, no, the slope is not 0. The slope of 0 is a horizontal line. That, you know, like this one right here. Y equals mx plus b. As you can tell, this x equals thing, there is no y value here. Your y can be whatever it is. No matter what it is, x will be equal to 5. You cannot divide by 0. Your answer for this, what I would like you to put, don't put no solution. Put undefined slope. Boom. There we go. That's probably the longest explanation I'll have for any problem. After that, I need to kind of move on from there. Vertical lines, this and that. All right, some more slope practice here. These are from the basic ones. I'll be very quick with it. Is the slope positive, negative, or 0? Let's go and match them up. I'll just draw a line to them. Positive slope, number 3. Negative slope, number 2. 0 slope is number 1. Now, negative slope. Here's your run, here's your rise. In this case, your rise is kind of like a fall. What I like to say is, as you go this way, right? When we say run, it's hard to tell if you mean right or left. So, like, that's why when we say rise or fall, it's easy to say if you're going up and down. So let's call run as going to the right. Unless I say run left. So by default, run would be going to the right. So we say as we run, literally as we go to the right, Are we rising or falling? In this case, as we run, we are falling. So your fraction, delta y over delta x, the signs will be negative over positive. And that number is a negative number. A negative number divided by positive number is a negative number. I could rise and run to the left, which would be positive over negative, which is still negative. It's just, you don't want to say it that way. It's going to be a lot easier to think of things as going forward, especially because if you have a word problem, it's in reference to time. So I want to really make sure that you're clear on that. Even with this one, we rise and we run, and that's why it's that. But even if you go to the left, you're also going down. So if I did negative over negative, that would be a positive number. So you have to remember, negative divided by negative is positive. Make sure that when you do a fraction, like there was one I was talking about right here. I think I said, I think it was this one. I said, when you put over 1, make sure it's a positive 1. As I run, positive 1, I will fall 2. All right, here we go. Part C. From there, find the slope of a line from 2 points on the line. Algebraically? What do they mean by algebraically? Find the slope of a line from 2 points on algebraically. I don't know what they mean by algebraically. That's okay. Maybe I'll figure it out from there. Alright, some proficient problems here. Find the slope of a line. I already talked about this here. I'm going to take, here's maybe one way of putting it. Call these x1, y1, and x2, y2. Like that. And you say, I'm going to subtract one y from the other and one x from the other. Whether I go y1 minus y2 and x1 minus x2, that's fine. Or y2 minus y1, x2 minus x1, that's fine. And then I divide. But you have to go from this to this and this to this. Or you have to go from this to this and this to this as you subtract. It's easier, once again, for me, it's easier to just look at which x is smaller and which one's bigger. Because I want to say, how many values do I, God, I don't know how to say this. How much do I run from -2 to 2? How much is it? Sorry, there you go. What's the distance between -2 and 2? There you go. Okay. Now I don't know why I'm doing delta x first. It doesn't matter. Delta y, delta x. But how much? -2 to 2, you got to do 2 minus -2, which is 2 plus 2, which is 4. And on top here, how much do you fall, literally, how much do you fall from -2 to 1? You got to do -2 minus 1, which is -3. Like that. So that's your slope, -3 over 4. You go down 3 and over 4. So you got to subtract one from the other, or you can literally count as you go through. Okay, number 5. Again, I'm going to do 3 minus 3. I'll do the top. Delta y over delta x. Let's do 4 minus -2. Remember, you subtract. To find the difference between two things, you must subtract. Even though I'm subtracting a negative number, I will then be adding 0 over 6, right? 4 minus -2 is positive 2. That is 0. Next one. Same idea once again. 5 minus 5 over. I'll just do 3 minus 8. Making sure I'm still going. I'm just going to take these ones and then subtract these ones. So 5 minus 5, 3 minus 8. I'll just be consistent with it. You might want to do the same thing. It doesn't matter. You'll arrive on the same answer no matter which way you do it. It's really your call. So that's 0. Okay, advanced. I think it's only advanced because the numbers are bigger. Maybe you have to reduce the fraction as well. We'll see. Number 7, like I said, I'm going to do 72 minus 40. I'm going to subtract my y's, find the difference. That's 32. And then I'm going to subtract my x's, 33 minus 51. 33 minus 51 is -18. Yes, it looks like this will have to reduce. Please reduce your fractions at all times. This is not -2, by the way. These can both divide by, I guess, just 2. So you'll get -16 over 9. That's as small as your slope can go. By the way, these are all m. And if you're doing y equals mx plus b, and you're trying to find the slope, because we're going to have to do this probably next, to find the equation of a line, this is your m value. You're going to use that as you go through. Number 8. What color haven't I used? Let's use purple. Let's do 90 minus 49. And this is as simple as the practice is. Maybe you want to plot these on a graph and then count what the difference is, and you'll get the same number. But with bigger numbers like this, it's not as practical. I wouldn't want to count 41 values all the way up as I go, and then 34 values across like that. And by the way, this number does not reduce. I don't know why they're giving you weird numbers like that. I have to make sure that that calculated correctly. It looks like it did. So 41 over 34. And finally here, I have 20 minus negative 13. Notice how I use the parentheses for that. I'm very much a stickler when it comes to negatives like that. And negative 61 minus 10. This is 20 plus 13, which is 33. Negative 61 minus 10 is negative 71. And once again, I do not believe that reduces. Negative 71, I believe, is a prime number. So there you go. Those are those problems. There's not much to them. You're subtracting one from the other. You have to make sure that you go the same way both times as you do it. And you also have to make sure that you reduce fractions as you go, that whatever else. Some people might ask, where does the negative fit in all this? Because I did recommend before you make this one positive as you run. That was just to say in words. Where does the negative fit? You can keep it there. It doesn't matter. Or make sure you know this is also the same value if I put the negative there. It's also the same value if I put the negative right there. If you see it on a problem, you're probably going to see if they write out the problem for you, you'll probably see the negative right in the middle. Okay? Understand, it's all the same thing. You got to put the negative on top or bottom, though, on one. Not both. Remember, that becomes a positive number. Okay, determine if two lines are parallel, perpendicular, or intersecting. Let me just give you the bare bones notes to this as we talk about it. Parallel means same slope. Perpendicular means opposite reciprocal slope. Opposite reciprocal slope, for example, means if you have a slope that's like 4 over 1, your opposite reciprocal slope, that's a perpendicular symbol, that's negative 1 over 4. Opposite meaning you change the sign, reciprocal meaning you flip the numerator and denominator values. These will yield perpendicular lines. Hopefully we have a chance to actually graph some of those in this thing today, but I only left less than a half hour, running out of time. I'm actually going to go a little more quickly. I'm doing the basic ones, though, because I think they'll go pretty quickly. Looks like they're already in y equals mx plus b form. Same slope, so they are parallel. Remember, slope is your m. Right here, here's a slope of 1/2. Here's a slope of negative 2 over 1. This is another reason why to write it as a fraction, so you know what possibly perpendicular. These are perpendicular, opposite reciprocals. So there's that one. Sorry for the handwriting. Finally, this one, I have a slope of 3, or 3 over 1. And this one's 1/3. They are reciprocals of one another, excuse me, but they are not perpendicular. Okay, if you were to graph these, I'm going to try and go super quickly with the graph, but if you were to graph these here, up 3 over 1, if you think that they both crossed like right here, go up 3 over 1, it looks like that, probably. Up 1 over 3 probably looks about like that. You could tell these aren't perpendicular. This one that crosses here, this one crosses here. Those aren't 90-degree angles. Meanwhile, if you look at 1 over 2 and negative 2 over 1, here's maybe 1 over 2, up 1 over 2 each time. And here's negative 2 over 1, down 2 over 1, down 2 over 1, etc. And it keeps going. You'll see if you tilt your head, terrible graphing, if you tilt your head to look at this as up and down and this is left and right, you can see like, oh yeah, that's a 90-degree angle. That's what perpendicular means, and that's where they come across. Okay, advanced. See, that's why I did those. There's no proficient. Advanced, I'd like to... Here's why it's more advanced. They don't have it in slope-intercept form yet, and it's really good. If you get it in slope-intercept form, then you know exactly where your slope is. So I'm going to isolate y, get y all by itself. Subtract x, I get negative x plus 2. Divide by negative 1, I get y equals x minus 2. So my slope in this one is actually a positive 1. It's 1 over 1, actually. 1 over 1. On this one here, I'm going to subtract x, I get y equals negative x plus 3. Now this slope, this slope is negative 1 over 1. So I have two slopes here, Positive 1 over 1, negative 1 over 1, are those opposite reciprocals of each other? Is 1 over 1 and this, are they? Well, opposite, change the sign, reciprocal, flip these. Yeah, 1 and 1, they flip, they'll still be the same, but yeah, these are perpendicular. By the way, on number 3, I didn't answer what the question was. These just intersect. They, excuse me, they are not perpendicular and they are not parallel. Therefore, they do cross at one point. They just intersect. Perpendicular lines, by the way, they do intersect. But intersecting means they intersect but are not perpendicular. Okay, this one right here, this one's in y equals mx plus b form. I have a slope of negative 1/3. Let's see what the other one is right here. Y equals, 3y equals negative x plus 6. Remember, I am subtracting x. Then divide by 3, I'll get y equals negative 1/3 x plus 2. Negative 1/3, negative 1/3. What you also have to be careful of, only because I don't know if it's going to pop up in the next problem or not, we'll see. Just because they have the same slope does not necessarily mean they're parallel. I'll give you an example. What if this said negative 1/3 x minus 3? Well, this one is also negative 1/3 x minus 3. If they were both the same equation, one goes like that, one goes like that. I guess that's not negative 1/3, but if they coincide, those are not parallel. They run on the same line, but they are literally the same line. Those parallel means not intersecting, which also would mean same slope. So here, you'd have to make sure that they are not intersecting, which they're not. This is plus 2, this is minus 3. So these are parallel. Okay, number 6. 6x plus 4y equals 6. Let's start solving for y. Subtract 6x, divide by 4, y equals, this is negative 6/4 x plus 6/4. This reduces to, negative 3/2 x plus 3/2. So you can see here the slope is 3/2 on the left one, and on the right one, 2y equals negative 3x plus 6, divide by 2, y equals negative 3/2 x plus 3. So once again, negative 3/2 is the slope for both. Awesome. Different y-intercepts, which means these two are parallel. All right, moving on. Because, I'm going to skip these basic, by the way. I got to move straight through. Find the equation of a line passing through the given point and parallel or perpendicular to the given line. So this is where I need to actually do the most, not the most teaching, but this is where the highlights come in, new chapter stuff. Parallel to x minus y equals 2 and through the point negative 2, 3. So what you're going to do is, here's a line. Let's put it in y equals mx plus b form for a good reason. It would be easier to graph, for one. And for another, there you go, subtract x, divide by negative 1. Here's that equation. What I want to do is find the equation of a line that's parallel to this one. And it passes through this specific point. So, not that I'm going to graph it very sharply, but here's y equals x minus 2. You start at negative 2 and you go up 1 over 1. The graph looks something like that. Okay. We're going to find another line that's parallel to it and it hits the point negative 2, 3. So it looks like this, and it goes parallel like that. So you can see it has a different line completely. It has a different y-intercept. Maybe you can already determine, maybe you can predetermine what you think that point is, but let's be exact. Let's use the numbers. Let's find a way to actually solve for this. You know it's going to be positive. Might be around positive 5. That actually might be the answer. I don't know. But how we're going to do that is, you have to know what the slope of this line is first. The slope of this is 1. It's 1 over 1, but it's 1. Right? Because when we say parallel, we need to have the same slope. So going into this new equation, we're going to have an equation that says y equals 1x plus b. And we need to find out what b is. And you can't find out what b is unless you have x and y. And you go, hey, we do. We have this x and this y. Let's use those. Negative 2 can go in for x here. 3 can go in for y. If I substitute those, use a point that you have, take those, use them wisely. And you'll get b equals, you get b equals 5. So your equation then, with a slope of 1 and a y-intercept of 5, is y equals 1x plus 5, or just x plus 5. That's your final solution. I am going to move along. There's not much time. Perpendicular to x minus y equals 2, and through the point negative 2, 3. So you can see this is the same problem with one difference, perpendicular and parallel. So, same equation. This is y equals x minus 2. Remember, as we rewrote this. Now, the original slope was 1. Okay? Or 1 over 1. If that's the case, the perpendicular slope, the opposite reciprocal slope, is negative 1 over 1. These guys flip. They're still 1, but the sign changes. So as the sign changes, we're going to now have y equals negative 1x plus b. Use the points negative 2, negative 3, or negative 2 and positive 3. Excuse me. Negative, let's try that again. 3 equals negative 1 times negative 2 plus b. 3 equals 2 plus b. Subtract 2, you'll get b equals 1. So your equation for your perpendicular line with a slope of negative 1 and a y-intercept 1 is y equals negative 1x plus 1. And that's your equation for the line that's perpendicular to that and crosses through that point. Number 5, let's go to parallel to this line. I'm going to solve for y once again. The whole idea is to get y by itself. So we have 3x, hang on, negative 4y equals negative 3x plus 12. So divide by negative 4, I get y equals y equals positive 3/4 x minus 3. I divided everything by negative 4. So parallel, once again, means use the same slope for your new line. Same slope is 3/4, so I'm going to have a new equation that says y equals 3/4 x plus b. And I need to find b. I have the point for negative 2. Let's use that. Let's substitute. Not much room here. I doubt I gave you much room on your paper, though, either. Negative 2 equals 3/4 of 4 plus b. Maybe you have to whip out the calculator, but 4 over 4 is 1. So you just have 3 there. So negative 2 equals 3 plus b. Subtract 3, you get b equals negative 5. With a slope of 3/4 and a y-intercept of 5, your equation will then be y equals 3/4 x minus 5. There you go. Sorry, I do have to work quickly. I'm very time conscious right now. And actually, I don't know. Let's see how much I have left. I might have a lot. Oh my goodness. I don't have any time for this. Here we go. Next one. I'm going to work super quick. Y equals 2x plus 2, or minus 2. Okay, perpendicular through. If the slope is 2 over 1, I'm going to make this slope negative 1/2. Okay, so I have an equation that's y equals negative 1/2 x plus b. I just didn't realize how much time I had, how little time I had. And, you know, I want to be time conscious for you guys. I want you to have a shorter video. 5 and negative 3 for x and y. This one gets a little iffy because you do have a fraction. So this will be 5 equals 3/2 plus b. 5 is 10 over 2, so as I subtract 3/2, b will equal 7/2. Sorry, I can't slow down for fraction practice. You will have to do some practice on your own here when it comes to that. Y equals negative 1/2 x plus 7/2 will be perpendicular to that one and passing through this point. Moving on, sorry. Write the equation of line y equals mx plus b form. I don't even know if I mean, honestly, I'm just going to write these down. If you have questions on what they are, you might need to, you might need to ask some questions. Negative 1/2 x plus 0 is also negative 1/2 x. So if you just see that, make sure you know. I think that's just because those are the basic problems. Write the equation of a line with this stuff. So this is like the same stuff that we were just doing. 4x plus b. Here's your slope. And your y and x values you're going to choose are these. I'm surprised these are coming after the perpendicular and parallel stuff. So once again, you're going to use the values you know. You know x, y, and m. And you'll solve for the rest. You'll solve for b. And when you do, you'll get your final equation here. And sorry, I'm not talking through some of this problem, only because we just did a problem like that. And it's y equals negative 4x minus 7. Same thing here, slope of 1/2. And this time I'm going to plug them straight in. 3 for y, 1/2 for m, 4 for x. Y equals mx plus b. Slope is m. This is x and y, remember? 1/2 of 4 is 2. And so subtract 2, b equals 1. So you get y equals 1/2 x plus 1. There you go. Oh, very time conscious now. I'm so sorry. Same thing. Y, m, x, and b. Negative 1 is negative 3/3. When I add 4/3 over, that'll be 1/3. So b is 1/3. So your equation then is y equals negative 1/3 x plus 1/3. Again, it's all about finding slope and y-intercept. In slope-intercept form, you literally need slope and y-intercept. Cross out basic. Write the equation of a line containing each pair of points. I don't know what these numbers are for, so I'm going to ignore those. I'm just going to do like 2 of these. Okay, I'll do this first proficient one. The thing about this is, once again, you need slope and y-intercept for these to work. You notice the difference between these problems and these problems is this one has an additional point, and this one had slope. This one works really well because you had slope. With 2 points, though, you can find slope. My slope will be negative 15 minus 3 over negative 5 minus 1, which is negative 18 over negative 6, which is positive 3. Now that I have a slope of positive 3, I can choose either 2 points here. Substitute. I'm going to choose the smaller ones. Choose either 2 points to solve for b after that. So I can do 3 equals negative 3 times 1 plus b. I keep writing b. 3 equals negative 3 plus b, so b equals 6. So your equation is y equals negative 3x plus 6. That's one equation. I'll do one here on advanced. Let's see what seems to be the most difficult. Let's just do this one. Number 8. I'm sorry about this. Time just ran very short. I probably spent too long explaining some of the earlier stuff. So negative 2 minus 1 over 5 minus negative 4. That becomes negative 3 over positive 9, which is negative 1/3. So your slope of this your line for this equation will be y equals negative 1/3 x plus b. And you have to now substitute x and y. You can use either. Let's choose this one. It doesn't matter which one. Negative 2 equals negative 1/3 times 5 plus b. You can't be afraid of fractions here. I'm going to bring this down. Negative 2 equals negative 5/3 plus b. Negative 2 is also negative 6 over 3. And as I add 5/3 over, I'll get b of negative 1/3. So your equation is y equals negative 1/3 x minus 1/3. And there you go. Sorry, I do have to move on. I really apologize. Find the equation of a line from a graph using slope and y-intercept to determine equation of a line. Okay, y-intercept here on number... Oh, basic, I'm skipping. Sorry. Time conscious. Y-intercept here is positive 2, so your b is 2. Your slope, you want to use a growth triangle of some sort. So as I run... So you want to find any other point. It doesn't matter which one. This one. As I run 1, I go down 1. So your slope is negative 1 over 1, which is negative 1. So your equation is negative 1x plus 2. On advanced, I feel so quick with this now, I'm sorry. Your y-intercept is 2. Once again, next one, pick any point, but pick a point that it runs through. Like a specific one. Like specifically, it's looking like it's running through this guy. These lines aren't very perfect in any way. But it looks like as I go up, as I rise 1, I run 3. So my slope is up 1 over 3, 1/3. So your equation is y equals 1/3 x plus 2. Moving on. Oh, was that it? Oh, yay. Okay, sorry. I went much more quickly. You want me to do one more of these? Okay, I'll do one more of these. Let's do this one, number 6 here. Find the equation of a line going through these 2 points. Your slope, I'm sorry, I was all time conscious, and suddenly I thought I had a lot more to go. I guess I went very quickly. So notice, this is a good one to practice because all these negatives and stuff. Negative 2 minus negative 2 is negative 2 plus 2. And this is 5 plus 3. So this becomes 0 over 8, which is 0. So that's my slope. So we have y equals 0x plus b. We have to sub in one of these xy values. Doesn't matter which. Let's choose 5, -2. So -2 equals 0 times 5 plus b. So -2 equals b. There's your y-intercept. So your equation is then y equals 0x minus 2, or y equals -2. And that's it. That's your equation. Remember, that's a horizontal line. The slope is 0. Okay, that's it, and that's all that I was able to do. Sorry I skipped some basics. I know I skipped some of these over here, but as I went through, I wanted to make sure I kept it short. It's a little over a half hour, but it's pretty good. Got through a lot of equations for you, and because this was your homework, I'm sure you got a good gist of what to do, and you can always go through the basic as well as you go. So there's some practice there. And by the way, if there's some other stuff you still have trouble with, because all of our different tests always have review of some other things as well, I'm going to start typing out some of the other videos that you can look at. Okay, these are for the different chapter reviews. I want you to use these. Just go to this link. It'll go straight to that YouTube video. I think this one's called Chapter 5 Closure. I think I messed up the first time I created the hyperlink. And there you go. Use all those. Especially, if you're going to do a benchmark retake or whatever else, do Chapter 6 review. Look at systems of equations, finding solutions of systems of equations. Chapter 4 review, I think, has a lot of things on graphing. Chapter 3 review, I think, has a lot of things on solving for x. Maybe, I can't remember anymore. Might have some word problems too. So this didn't have any word problems, but this is what I wanted to do the video on here. Okay, I am signing off. Hope you enjoyed it. I know I talked quickly. You're going to have to pause, rewind, and do what you need to do. Again, very time conscious there. Ask any questions as you need to. Thank you.